basic objective of Hadoop is to ensure that we have the required approach in order to ensure that we are able to handle big data where we are distributing data in various disks and we are able to invoke a number of parallel processes in order to access data faster. I also told you that Hadoop plays complementary system of Java. Yeah, I'll do that. I'll do that. That's what will be my objective today. My objective today will be to ensure that people are aware about what part of Java actually we need. So I'll be talking about Java as well, so that we are on sync, and next session onwards we can start up with installation setup and then start writing with the programs itself. Okay, fine. Now, as I told you that basic objective of Hadoop is to ensure that access is faster, and we know that Hadoop will be used when you have scenario like write once and read many times, where you are about to use or you are going to use something called as MapReduce, which is a programming model in Hadoop, in order to ensure that you are able to do data analytics and you are able to get the right piece of data from a repository where data is coming from diversified sources. Okay. Now, most important component, if you see in Hadoop, as I told you, is the file system, the way data is organized on different machines, the way data is managed on different machines, the way data is kept on different systems in order to ensure that in case if there is failover, recovery is possible. So in order to make all these possible, Hadoop adopted a unique file system, and that file system is what is called as Hadoop distributed file system, or you can say HDFS. Okay. Now, that is what is my objective today, to ensure that we are able to understand what actually is Hadoop distributed file system. I'll be providing all notes from various books in order to ensure that we are up with interview questions as well, apart from definitely giving you sound hands-on experience on Hadoop. Okay. Now, let's talk about this distributed file system. Now, here we have a term called distributed. Now, what do we mean by distributed? Meaning of distributed is distribution of content, distribution of data, right? So when we say distributed systems, we have to understand from two different concepts. One is distribution of data across different machines, and second is distribution of processes across different machines, where in case of distribution of data, we share a number of organized, pre-organized disk which is there on community hardware, not specific hardware. And when we talk about distributed process, it is a number of processes distributed across different machines in order to get best possible performance. That is what is the meaning of distributed term here. Now, Hadoop adopts Hadoop distributed file system, that is HDFS, right? Now, let's understand what actually this file system is all about. Now, when we say that when a data set outgrows the storage capacity of a single physical machine, right, it becomes necessary to partition it across a number of separate machines. Now, if you see file system that manages you say data across a network of machines is what is called a distributed file system. So this is actually definition of distributed file system. That is, capacity of a single physical machine is over now. Now we have to ensure that data is shared, or it is being it is being arranged on a number of machines, right? Now, if you see, when we talk about distribution of data across different machines, you will have certain problems, right? Like all machines will be connected to network, so you will have complications of network programming, right? Where distributed file system seems to become very complex when it comes to large disk file systems. Okay, so if you see, when we talk about challenges which are there in managing the file system. You will have making that file system more tolerant to failures, right? And when actually there is failure, you cannot compromise the data. So it means that you need a robust file system which makes your file system tolerant from data or node failures without suffering data loss. Okay. Now, this mindset is what was adopted when they actually came up with file system for Hadoop. Okay. So if you see, basic objective of file system abstraction, which actually they provided, was with prime objective of providing highly fault tolerant system, right? With very good throughput, with you say with very huge amount of data. Or when we say HDFS basic objective was to provide a fault tolerant system which is capable of handling huge files. Okay, when we talk about huge files, my context here is in terms of hundreds of megabytes, gigabytes, or terabytes. Okay, so in order to ensure that we are able to ensure that data is not getting lost and we have a very robust recoverable file system, actually Hadoop came up with concept of HDFS. Okay, so now if you see today, Hadoop is running on huge clusters that stores huge amount of data, you can say in terms of petabytes. Okay, so this is what actually is basic objective of HDFS. Now, let's talk about features of HDFS, where I told you highly fault tolerance, high throughput, right? Other objective of HDFS is streaming access to file system data. If you see here, streaming access to file system data, meaning is if you talk about HDFS is again built on basic idea of that it provides you data processing pattern where you adopt write once and read many times pattern, right? So if we talk in terms of building blocks of HDFS, you will say that there is a data set which is generated from various sources and then they are copied, providing you capability of analyzing that data which you can perform on that particular data set over time. Now, when we talk about what do we mean by analyzing the data, it means you will have a large proportion of data set being read during a particular fixed amount of time, right? In order to ensure that whatever is the throughput that you expect during that particular throughput, you have some kind of analysis done. That is what is objective of streaming access to file system data. Now, when we say can be built out of commodity hardware, meaning is Hadoop doesn't need expensive, highly reliable hardware. It's basically designed to run on cluster of commonly available hardware that can be obtained from multiple vendors. You need not go with IBM huge servers or Sun huge servers, right? You can use commodity hardware and you can put all those commodity hardware in a cluster where HDFS will be placed with objective of working without interruption to the user like failure and all. So that is what is one of the features which makes Hadoop very popular. So if now I talk from terms of what actually will be the questions when you will attend interview, you can say that basic questions will contain questions like why actually Hadoop adopted HDFS. So answer to this should be Hadoop adopted HDFS because HDFS commits highly fault tolerant, better throughput, you can say provides assistance to applications where large data sets are needed and provides you capability of doing analysis in real time pattern and doesn't need any hardware which is specific. We can use it on commonly available hardwares, right? So this is what makes Hadoop very popular, right? So this is what actually I wanted to share with you regarding Hadoop. Now, if you see, this slide will be shared with you. Now, I'm coming to something which is again a very important feature of Hadoop, and probably in first session I might have definitely given some idea, right? And that is what is MapReduce. Now, when we talk about, fine, I have set up my hardware where I have set up a cluster, and that cluster actually involves a number of machines where I have distributed my data on the adopted file system within HDFS. So how actually we'll be doing analysis? In order to do analysis, there is a programming model adopted by Hadoop called as MapReduce, right? Now, MapReduce works in two phases. You have this data which is available. This data is split, and then it is passed to two different processes. One is called as map, second is called as reduce, right? Now, this map and reduce will give you the required analyzed data that you expect, which you can combine and use as value object. Fine. So this is what is overall idea of MapReduce. You can say MapReduce is a programming model which is adopted by Hadoop in order to help us in doing analysis on huge data available on various disks in a particular HDFS cluster, and it works on principle of two different stages. Stage one is map, where we use a mapper in order to classify to Hadoop system about the data that we need. So you will be passing key and you will be getting value, right? And then you have a reducer phase where actually you go and apply the logic which helps you to extract the needed content. So in short, Hadoop is combination of these two different components. Okay. If you have any confusion, you can type in the question. Is it clear? Okay. Fine. Now, let's talk about architecture of HDFS. HDFS is made up of what? Right? Once architecture is there with you, I feel that you will be able to understand the internal working of HDFS, and then I will be showing you how actually you can go and you can use HDFS. Okay. Like if you see in very simple terms, if I say you have PAT, like file allocation table, which is used by Microsoft Windows, right? Now, in order to interact with file system, you will have commands where you go file copy and you do various tasks on this. Similarly, HDFS also, you will set up your Hadoop and then you will organize, you will make your disk formatted to hold HDFS file system, and then you will interact with it using various commands, and that is what we will discuss also. Okay. Now, when we talk about what actually is HDFS made up of, now keep in mind one thing, that when I say HDFS, immediately you should understand that you have multiple nodes, and on those nodes you have your data organized. Okay, so typical organization of HDFS is of this form. Now, if you see, it is combination, or it is HDFS is combination of two different type of nodes. Okay, or you can say an HDFS cluster contains two types of nodes. First one is master node, and if you say second one is data node. In short, Hadoop file system works on principle of master slave or master worker pattern, right? So you'll have master worker pattern. This is what is adopted by Hadoop file system. Okay. Now, if you see, typically master node is called as name node, and worker nodes are called as data nodes. Okay. Now, objective of name node is to ensure that entire file system and work which is going on the file system is controlled by your name node. The name node is a master server that manages file system namespace and regulates access to file by clients. Okay. In short, your name node maintains the file system tree and the metadata of all files and directories in the tree. And this information is stored permanently on the local disk in form of again 2 files. Okay. So if you see, when we talk about name node, information is stored on local disk. Okay. In form of 2 files. If I say what all the files, first one is very important, namespace image. Okay. And second one is edit log. Fine. So in name node, information is stored on local disk in form of 2 different files. One is namespace image and second one is edit log. Okay. It's clear. Now, when it comes to data node, this data node actually is something which contains all blocks, or which is the building block of your HDFS file system. Okay. Clear. So if someone is asking is what will be there in data node? Data node will contain all blocks. But please understand that it does not store block location persistently or permanently. Right? Because every time your information will be reconstructed from data nodes when the system starts. Okay. So you can say it builds in memory data blocks. This is what is data node. Now, if you see, data node manages storage attached to the node that they run on. Right. So each data node, which is worker node, is responsible to manage data or storage which is specific to them. Right. Now, if you see, names HDFS exposes a file system and namespace and allows user to be stored user data to be stored in files. Then a file is split into one or more blocks and set of blocks that are stored in data nodes. Right. And if you see, data node serves read, write, request, perform, block creation, deletion, and application of all instructions from name node. Right. So you can say all instructions when we talk about a client. Now, a client accesses the file system on behalf of user by communicating with the name node and the data node. Right. Now, the client presents basically a file system interface. So the user code does not need to know about the name node and data node to function. So in other words, when we talk about Hadoop, it makes your client layer abstract from the actual setup that you have. Right. For example, how many name nodes are there, how many data nodes are there. When a client will make access, all this information is not required. Okay, because client will have a file system interface through which he will be submitting his request. Okay, it's clear. So once again, name node is the master node and data node, you can say, are the basic powerhouse of the file system. Okay, when we say powerhouse, it means they will store, retrieve, block whenever a client will try to access it or whenever a name node will demand. Right. It's clear. One of the very important features here is heartbeat. Your data node will always, during a particular period of time or after period of time, will always share its heartbeat with the name node. Now, this will ensure that your name node is aware that what all data nodes are down and what all data nodes are up. Okay. So there is proper coordination between name node and the data nodes. Right? Your master node will always keep track of information flow which is going on in DataNode, right? And that will be done periodically, right? With list of blocks, whatever they are working. So you can say DataNode will keep on informing NameNode about whatever goes on in the DataNode. Still, if you see, you cannot imagine file system actually without NameNode. Okay, or you can say without NameNode you cannot interact with HDFS. Okay, so now let me put a scenario in front of you and ask you what you will feel that HDFS will behave like. Now, if you have a name node and various data nodes, right? You have installed HDFS in a cluster running on various machines. What happens if name node is down? What happens when name node is down? Okay, let me give choices. File system will crash. It's true or false? Yeah, Kasi. File system will not crash. Okay. So what will be their effect on the system? So if you see in this setup, I'm saying master and then I'm saying slave. Then I'm saying that master will contain metadata about all slaves and slaves will periodically keep on informing about work which is going on in their nodes. Now here we are talking about machine running name node was shut down. Right? Now please understand that you need to have proper architecture in place. So if name node or machine on which name node was running is shut down or it fails, all the files on the file system will be lost, since there would be no way of knowing how to reconstruct the files from the blocks on the data nodes. Okay? It's clear. So I am very straight. I am telling that if machine on which name node is running is down because of some reasons, it is very clear that all files on the file system will be lost because there will be no one to coordinate with data nodes and reconstruct the files from the block on the data node. Right? Because of this, it is important to make some arrangement. Because of this, it is important to make the name node robust to failure. How it is done in Hadoop. What you said, I agree to it, but here, if no name node is there on a single box and it is managing the cluster, in case if name node is down, you cannot expect your Hadoop to be up. In order to ensure that this problem is not there and your name node is robust, Hadoop provides two different mechanisms. Okay, so we are talking about what happens when name node fails. Let's talk about first approach. Now, if you see, the first way is to back up the files that make up the persistent state of the file system metadata. Okay, so you have to go and on a continuous period of time take the big backup. Right. Now, Hadoop can be configured so that name node writes its persistent state to not only one file system but to multiple file systems. And please ensure that these writes are synchronous and atomic. Okay. So here, if we go and talk about what happens when there is a failure, we need to understand that we have to adopt some approach where your system is not down, and in order to do that, there is a suggestion which we can take, that is, ensure that you have configured your HDFS in such a way that backup of the files is being taken on a continuous period of time to ensure that whatever metadata is required in order to make your system up or delegate responsibility to someone else, that is made available, right? And these writes, whatever you are writing, must be synchronous. Okay, fine. So here you can adopt actually a file system, or you can say configuration, where you're writing to local disk as well as you're writing to some remote NFS mount. Okay, it's clear. So by making this arrangement, you are making your name node live, and it is always there. Okay, this is what is first option. Now second option, why not to have one more secondary name node? Okay, when we say we are going to have a secondary name node, it means that it does not act as a name node. Its basic objective is to periodically merge the namespace image with the edit log to prevent the edit log from becoming too large. And when it comes to when actually secondary node will be up, it will be up in case if main name node is full. Okay, so you can say that second arrangement that we can do is to have a secondary name node which runs on a separate physical box. Okay, because when it comes to name node, it requires plenty of CPU and as much memory as your previous, or you say actual name node is having. So here objective of secondary name node will be to keep a copy of namespace image which can be used in the event of name node failing. Okay, so there are two different arrangements which can be made in case if you want to go with robust name node configuration. Okay, so let me come back again. Important component when it comes to HDFS architecture is what? There are two different type of nodes. One is name node, which is called as master node. Second is set of data nodes, which actually contains blocks, data blocks, right? If you see, it is in-memory data blocks which is made with persistent information about which metadata is there with name node. Okay, client, when he will access your file system, he will not be bothered about the architecture of your name node and data node. So client interacts with HDFS through an interface, which makes your client decoupled from the architecture. Right? Then comes question which I asked you: what happens in case if your name node is down? In order to answer it, I told you that if you have not made any arrangement, your file system will go. Right? You will not be able to interact with the file system because all the files on the file system will be lost. Right? Why it will be lost? Because it is name node who actually contains or has capability of reconstructing the files from the blocks which are there on data. In order to ensure that this particular failure is not there, you can go and you can tweak your architecture. And there are two different ways of tweaking it. First way is keep on taking backup in synchronous way, probably on a different box. Second is have a secondary name node which takes responsibility of periodically merging the namespace image along with edit log on a different box. And whenever it is failing, you can go and upstage that secondary name node to behave as primary. Okay, so till here everything is clear. Numan, is it clear? Am I audible? Okay, thank you. Fine. So if you see client interacts and metadata is there in name node, it is created, and then you will go with, or your name node will go with reconstructing the data, picking it up from various data nodes. Okay. This is what are the two important components. It is fine. Okay. Now, let's talk about something again very important. Now, if you see, as I told you that your name node will keep a reference to every file and block in the file system, which is there in memory, right? Which means that on very large clusters with many files, memory becomes a limiting factor for scaling. In other words, I'm just asking a simple question here that, see, now we have seen role of name node. All reconstruction and everything is being done by name node. So basic question that comes up here is, how much memory does a name node need? Okay. It's clear. It's a question, right? Now, if you see, in order to ensure that you're able to scale up to a particular level depending on your need, who is going to configure name node? We are going to configure. Yeah, administrator is going to configure. Whoever is setting up the cluster, he is going to configure. Okay. So, like any other operating system, you will have bootstrap. Similarly, HDFS will also have bootstrap, where it will have a config file. In that config file, you have to specify all the parameters that you expect your HDFS to have when it is mounting up your file system. Okay, and all that we will be discussing. Right. So, see, activities which we are going to be, they're pretty simple. Only thing is understanding the architecture, because this shift from basic computing is what makes Hadoop a bit complex. Okay. Otherwise, when it comes to working with Hadoop, writing programs, it all depends on how well you are in organizing data, which is coming from multiple sources. Okay. Now, in order to ensure that you are able to have a capability of scaling up the system, HDFS was introduced in 2.x series. Okay, basic objective of HDFS was to have federation capability, where you can federate. Is HDFS a one-time task? Let me know. It actually depends on the architecture that you have adopted. If you have done proper architect, as a proper architect, if you have identified the amount of data, how huge data it is going to handle in coming next 10 years, and if you are able to dedicate that much of storage to it, it's fine. But if we talk about, we have not probably done the right analysis, because data is coming from diversified sources and we don't have control over amount of data which is being pushed in the system. Okay. It's clear. Name node. Kranti, name node, if you see, as I told you that when it comes to name node, typically you will have one node up, but you need to ensure that you are keeping your architecture robust, and for that you have to ensure that you are adopting an architecture where failure of machine wherever you have name node is not affecting the entire architecture. For that we will go with having multiple, you can say at least one secondary name node. Okay. So if you see, I was talking about a solution. That solution is The problem was how much memory does the name node? And solution is you go with federation. Okay. For example, you may have name node which might manage all the files which are there under X folder, you say, and you may have another name node which manages files which is there in Y, you say, directory. Okay, so here you see you are federating responsibility, fine, where each name node manages a particular namespace volume, and that particular namespace volume is made up of metadata for the namespace and block pool containing all the blocks for the pool in the namespace. Okay, so if we say here that what actually helps us in order to ensure that our system is scalable, that is possible by using something called as federation. Meaning of federation is distribution of tasks. Okay, to various, I'll answer it, to various name node, where each name node manages a portion of file system namespace. So tomorrow, if you need to scale it up, just go and add one more name node and dedicate or allocate it a particular namespace. Okay. It's clear. And please understand that this capability was introduced in 2.x release. Okay. Is this clear? Fine. So if you see file system namespace, hierarchical file system with directories and files, create, remove, move, rename are the operations. Name node maintains the file system. Any meta information changed to the file system is recorded by name node. This is the reason why we have to keep our name node robust. An application can specify the number of replicas of files needed, replication factor of the file. This information is stored in name node. Right. Then important one is federation. How actually you will come to know that how much memory we should allocate to a name node, and this is done by federation. Meaning of federation is you will have to distribute tasks to various name nodes where each name node manages a particular namespace volume. Okay, and that particular namespace volume, as we know, that is made up of block pool containing all blocks of files in the namespace. Right, and please understand that these namespaces are independent of each other. Okay, when I say independent of each other, it means name nodes do not communicate with another name node who is basically managing others. Now, what is reason behind it? The reason is failure of one should not affect availability of namespace managed by other namespace, other name nodes, right? So if you have a number of name nodes and if you feel that they should replicate information to each other, what if one fails? Problem will be there. So in order to ensure that, we will say that all namespace volumes which are there are independent of each other. So if namespace volumes are independent of each other, it means name nodes will not communicate with each other, right? And why have they adopted this particular approach? They have adopted this approach in order to ensure that if failure is there in one name node, it does not affect the availability of managed managed namespace by other name nodes. Okay. It's clear. So this is what actually is namespace. Now let's go and add it up to our existing understanding about HDFS. HDFS is a robust file system, works on principle of master-slave, where master is name node and slave is data node. Name node actually contains existing, you can say, right, which we are using in with the terminology called as namespace, and it is name node who actually regulate or controls blocks and reconstruction of data from various blocks which are stored in form of files on various data nodes, right? So in case if name node is down, you will not be able to communicate with the Hadoop system. So in order to ensure that system is more robust and name node failure can also be tackled, we have two different approaches. One is go on with backups, probably on distributed environment in synchronous and atomic way, and second approach is to have a secondary name node, right? And then we came and we spoke about a very important feature of name node where we have to decide that what amount of memory you need to assign to your name node. The answer to that was, since we cannot keep on outgrowing the memory, we have to go and adopt approach of federation. And meaning of federation is very simple. It is distribution of tasks to various name nodes, where each name node will have a dedicated portion of file system namespace. Here, in case of HDFS federation, name nodes which you have created will not affect each other. In other words, they will not replicate information or communicate with each other, in order to ensure that failure is not distributed to other name nodes which are there in the system. And this federation capability was adopted in 2.x release. Okay, it's there. Fine. We will be discussing about other architectures also, like what is active, what is active passive kind of environment, or this setup that we will be doing. Okay, so all that we will be doing. Objective here is to ensure that we are using terminologies. Okay, proper terminologies of the group. Fine. Now comes data replication. Now let's talk about a replication. Okay, what do we mean by replication? Objective of replication is again to ensure that failover is taken care. So, in order to ensure that if a system fails, data, whether it is metadata or data itself, is not lost, and you should be able to recreate the sessions when actually there is failure. You can go and you can adopt some kind of replication mechanism. Okay, you have various type of replications which we will be discussing, but here if you see, HDFS is designed to store very large files across machine in large clusters. Each file is a sequence of blocks, block which is the smallest unit of data storage. All blocks in the file system except last are the same size, right? It means blocks are divided into equal chunks of data. Blocks are replicated for fault tolerance. Block size and replicas are configurable per file, right? All that I will show you where you will configure and all. Then the name node receives the heartbeat and the block report from each data node in the cluster. And this is what I was talking about, that how actually your name node comes to know that what all data nodes are up. Okay, that is through heartbeat. You can go and you can configure this also, that what should be the interval of heartbeat sharing. Then comes block report, contains all blocks on a data node, right? So replication here again can be controlled or can be configured. For example, you have two types of or two strategies of replication. First one is full replication. Second one is partial replication. Recently updated blocks is what will get replicated, right? So you can go and you can adopt various replication strategies, which we will discuss once we will come to the right stage. Okay. Fine. So I will be talking about replication more once we go and we set up. Okay. Now, if you see Safemode Startup. Now, if you see on startup, name node enters safe mode, right? And you all know what actually is the meaning of safe mode. Replication of data block do not occur in safe mode. Each data block checks with heartbeat and block report. Name node verifies that each block has acceptable number of replicas. After a configurable percentage of safely replicated block checks in with name node exits from safe mode, right? So if you see, when you boot up your Hadoop and when HDFS is mounted, it actually enters safe mode, right? Where replication is, you can say, suspended, and basic objective here is to ensure that your name node is going and it is actually checking up all data nodes, right? And block reports. Then it verifies each block that it has acceptable number of replicas. And after that, it comes out of safe node and it makes the list of blocks that need to be replicated. As I told you, that there will be adopted strategy of replication. Right. So this is what is meaning of safe mode startup. Okay. Fine. Now, think of an operating system. You will definitely have metadata that you have to store, right? And if you say similarly, namespace, HDFS namespace is stored by name node. Name node uses a transaction log, which is called as edit log, that records each and every activity that is going on in the file system. Okay, like you are creating a new file, you are changing the replication factor, you say doing any activity for that matter is what is recorded in the edit log. Okay, that is the entire file system namespace, including mapping of the box design and file system properties stored in a file called as FS image. Right, I'll be talking about this in detail. As of now, my objective is to fill your brain with HDFS. Right, so there is HDFS file system, robust file system. We have concept of replication there. We have concept of name node. We have concept of data node. Works on principle of work. You can say master and worker. We need to always ensure that our architecture takes care of failure of name node itself. For this, we have different strategies. We are discussing as of now how we will discuss that once we set up our Hadoop on our machines. Okay, fine. Right. So if you see name node, setting up your name node keeps image of entire file system namespace and file block map in memory. 4 GB of local RAM is sufficient to support the above data structure. When the name node starts up, it gets the FS image and edit log from its local file system that we will see, updates FS image with edit log information, and then stores a copy of FS image on the file system as a checkpoint. Okay, so you can say periodic checkpoint is done so that system can recover back to the last checkpoint state in case of a crash. Right, so it is namespace, name node, which takes responsibility of periodically updating its own FS image and edit log so that in case if there is failure, it is able to recover. What decides the acceptable number of nodes? Rajini, see, when it comes to making decision of how many nodes need to be there, it entirely depends on the targeted volume of data that you are going to have. Okay, so you can keep on growing number of nodes which you have depending on the requirement. Right, so this will always be done by architects when they will come and they will say what amount of data you are going to handle, how many petabytes, and what is the best possible architecture to work with that. You will be setting it up, you will be doing unit tests, you will be doing load testing, all type of testings you will do, and then you will decide, right, at what amount of data, what amount of nodes actually are needed. You don't have any fixed formula for that. Okay, fine. Now, I feel that few things are there now with you when it comes to what actually is HDFS. DataNode stores data in files in local file system. DataNode has no knowledge about HDFS file system because it is all controlled and managed by your name node. It stores each block of HDFS data in separate files. DataNode does not create all files in the same directory, right? It uses some algorithm to determine optimal number of files per directory and creates directory in right way. Okay. When the file system starts up, it generates a list of all HDFS blocks and it sends this report to name node. Fine. So this is what is the responsibility of DataNode. They will just do tasks. They will keep the files, and once file system starts, they quickly create a report, block report, and they will send it to name node, where name node decides do he needs to replicate it, right? So he will collect all blocks from various places and then he will decide what he has to do. Is this clear? So, I do understand that you might be feeling a bit heavy, but all these terminologies are there which are important. And believe me, working with Hadoop is not at all difficult. Okay? Because most of the things are done by open sources which actually Hadoop adopted. Yes. Yes, Umar. It does that, but when it shares the information, it is an HDFS. Now comes protocol. See, we are in distributed environment. We are in network environment, right? So protocol becomes important because machines are of diversified type. You have types. You have some Linux boxes. You have some Mac. You have some AIX. You have some Sun Solaris where you have actually a plan to create your data nodes, right? So if you see all HDFS communication protocol are layered on top of TCP/IP protocol, right? So this becomes core. Fine. Now a client establishes a connection to configurable TCP port of name node machine. It talks client protocol with the name node. The data node talks to the name node using data node protocol. It's clear. So if you see, you will have an architecture where your HDFS main communication protocol is TCP. A client will invoke connection to TCP port, right? Targeting that particular machine on which you have name node, right? And then that interface, client interface, will take your information and talk to the name node in a special protocol called as client protocol. Okay. Now communication between name node and various data node is done using data node protocol. Right. So these are three protocols are there which actually comes into picture. One is TCP, second is client protocol, and third is data node protocol. Right. And if you see, data node protocol and client protocol is abstracted from you by using RPC. Okay. So you have RPC abstraction which wraps up both protocols. It's there. And if you see, request will always be invoked from data node or client. Right? So you can say name node is someone who will just sit quiet. Whenever there is a request from client, he will do his task, or whenever there is some block node information or heartbeat information is coming from data node, is what will be specified. Yes, it is remote procedure call. No one. Yeah, right. Fine. So if you see, when it comes to communication protocol, client protocol and data node protocol, these two abstracts or hides the underlying protocol, right? Name node is respond only. Okay, it never requests. It waits for client request or for data node request, and then it does its task. This is what is responsibility of name node, right? These are the protocols that you will be using. Is it clear? So if someone is asking you how name node and data node communicate with each other, you have to answer name node will never initiate a request, or whenever request will be made, it will be made by client or data node, and that actually will be done by data node protocol, right? Which is nothing but it's a remote procedure call, definitely written by Hadoop people, and they might be using various type of channels internally. Okay, is it clear? Now comes robustness, right? Now, if you see, you may get questions of this kind also. So how you are so sure that you are going to have most robust system when you adopt Hadoop? So you can say that the primary objective of HDFS itself is to ensure, or it is pessimistic in its approach. It feels that data will be lost. So in order to ensure that your architecture is saving your data loss capability, HDFS comes with that particular feature, right? So here if you see, there are three different types of failures, common failures. One is name node failure, second data node, and third is network partition. Okay, so these three types of failures are there, right? Now, how actually these failures are targeted and are known to the master. Okay, so if you see data node failure and heartbeat, a network partition can cause a subset of data nodes to lose connectivity with name node. Name node detects this condition by absence of heartbeat message. So as I told you that you will have all data nodes sharing their heartbeat with name node at a particular period of time, or periodically. You can say every 10 nanoseconds and all. So as soon as name node finds that there is, or you can say name node considers only those data nodes as active data nodes about which he has received the heartbeat message. Okay, so if you see name node marks data node without IO request to them, assuming that they are dead, right? Now any data registered to the failed data node is not available to HDFS. This is the reason why we manage this situation by going for a replication, right? Now death of data node may cause replication factor of some of the blocks to fall below their specific value, right? So you can say that failure is detected of data nodes by name node through heartbeat. Name node not receiving heartbeat from certain data node marks it, and it never delegates any IO activities to them. Okay, so this is what is data node failure. How to come out of it? You can come out of it through replication, right, or re-replication. Right. So you can say solution to failure or keeping your system robust always is replication, right? A data node may become unavailable, a replica may become corrupt, a hard disk on data node may fail, or replication factor or block may be increased. So if you see, this is what actually is adopted solution. I'll tell you how actually you can do it. Then comes cluster rebalancing. Right. Now if you see, HDFS architecture is compatible with data rebalancing scheme. Okay. So when I will talk about clusters, I'll be talking about that. As of now, basic terminologies I feel about HDFS is clear. Right. Now let's come to how actually we will go and install before we talk about this. Okay. Now, when it comes to installation of the loop, it's not very complicated. Okay, what you need to do here is you need to have following information gathered about the system. First, what is the OS? right? This is what is very important. Second important information that you need before you go and install Hadoop is what architecture is, right? What architecture you want to set up, like how many name node and all, whether you want to go with clustered architecture or you want to go with non-clustered architecture, like all this you have to decide. Fine. Now please understand that Hadoop actually in production expects Linux or any flavor of Unix. It never means that you cannot go with Windows. On Windows, setup is development only. Okay, but for production, this is what is preferred. Okay, fine. So this is what actually you need to understand. Now, how you will make your system ready for installation of for Hadoop, right? You need to download. Depends what actually you are using. VMware and install, right? It's Ubuntu, Balav. Ubuntu is what is the preferred one. Okay, but you can use any. It's Hadoop is lightweight actually. Download VMware and install it. Then next thing that you have to do here is make a machine. Yeah, all that I will show you also. Trust me, don't worry. For example, if you see this is what is my VMware, right? I am shutting it down. If you see, I'll just right. This is Mac. On Mac I have installed. If I go here, I have VMware Fusion. Like you see, once you install, you'll get this. Can you just tell me what operating systems you have? All Windows 7 or okay? Everyone is having Windows 7 only. Okay, great. Kranti, Ubuntu is there, so I feel that is good. It's fine, Numan. Okay. And let me just bring it to the initial stage. Now see, in order to actually start working with Hadoop, as I told you that we need to, better is to always go with Unix-based or Linux-based systems. So what we will do is, we will also follow the same thing. Now what you can do is, you can download or you can have Linux which is freely downloadable from somewhere, from Ubuntu site itself. It may take some time, or you wait for today I will make the same virtual machine available. But in case if you want to create your own, download VMware. Now for different operating systems you will get different flavor of VMware, right? This is for Mac, VMware Fusion, right? And see, if I want to create a new machine, I'll just go select file, new, right? And if you see, this will guide you through installing Windows or another operating system in virtual machine on your Mac, right? Please insert the installation disk. So if you have Ubuntu or Windows or whatever, you want to create a virtual machine with the desired operating system, you can go ahead. Now, if you see, please insert the disk. I don't have the disk, so I'm just going continue. I will choose a disk image, right? Or use a existing virtual disk. So I can go and I can select an existing virtual disk and I can create. Okay, but I'll be sharing this with you, or you can go and create a custom virtual machine as well. Okay, now when you go and create a custom virtual machine, this will be a virtual machine which you are going to create. Select your operating system that you want, right? For example, you can go and you can select, you say Linux, and if you see various are there which you can create. I'll just go and click on continue. You can at yes you want, click on finish. You want to save it somewhere, so you have virtual machines, you can go and you can save it there, right? And if you see here, you will get your virtual machine created, right? So it's pretty simple, it's not at all complicated. Only thing is you need to have VMware Fusion for Mac or for any other operating system. For Windows it is more simple. You have to just go and download VMware Workstation, okay? And you have to, I'll be providing you the steps also, right? And I'll be providing you one copy, right? So if you see, no operating system was found because I have not inserted the disk. Once I have inserted the disk here, automatically it will go and it will start the virtual machine. Okay, is it clear? I'll be sharing document with you which will be step by step. This is what we do. Now it's not that we cannot install at all Hadoop on Windows. We can do that, but we have to go and use some tool like Sigwin and all, which replicates or which can be considered as a replacement to your existing Unix, or having a flavor of Unix in your Windows environment. Okay, is that clear? Fine. So I'll be taking up one on one, and I'll be passing on information to you. I'll be sharing a file also to you. Our basic objective should be, we should know installation in almost all environments that we have. Okay. Any one of you is having Mac or use Mac so that I can. Are you using Mac? Okay. Now, if you see, assume that you have installed Hadoop. We'll be doing the installation to document. Once I get the data from them, then I'll be sharing it on blog where you can follow step-by-step approach in order to install Hadoop. But basically, if you see, Hadoop is a distribution which is distributed free of cost. What you need to do is you need to just make your machine capable of doing installation of Hadoop, right? For that, you have to bring in a Unix environment in your Windows, and that you do by installing Segment kind of utility. Once environment is prepared, then what you need to do is you need to go and extract the distribution, right? After extracting distribution, you have to ensure that you have the right permissions, right? So on Unix, before you go and install, you need to ensure that you have given the right permissions and all. That's all we will be doing, or we will be specifying in the document, which I'll share with you for installation, right? And once you have done that, then you will get utilities in order to install. For example, if you see, this is what is a distribution where you have. Okay, now if you see here, I can go and I can start Hadoop instance. Now this is a simple one. I'll be doing clustered one also along with these people, right? So if you see, now this Hadoop process has started. It is running, and if you see what all it has done, DataNode running as a process, it's already running. Now secondary name node running. So we have DataNode, we have name node, and we have a secondary name node, and they have started as different processes. Now since we have only one box as of now, we are using only one box on which we have created these three processes. Okay, so depending on the setup, you will have various ways of starting up your Hadoop. Okay, now agenda here is to make your machines up with Hadoop so that we can go and we can work with it, right? Now better is to have an image so that we can work in actual client server environment. For example, if you see here, Hadoop is running on a virtual box, right? And we have Eclipse on a different box. Now this is what is a place where I have Eclipse. I have extracted it. I'll just go and launch my Eclipse. If you see here, I'll just launch my Eclipse. This is what is my Eclipse environment. Fine. Now if you see, you need to know how actually you will make your Eclipse aware about, or you will make your Eclipse powered by plugins so that you can go and directly write MapReduce kind of programs. If you see, you have MapReduce location here because I have configured it. I'll show you how to configure also. You will write here Hadoop server, right? Now this particular property will be IP address of your Hadoop instance, right? If you see, it is 192.168.2.128. So I'll just go and write here 192.168.2.128. Okay, so this is what is IP, which we have specified. Now comes port. These are the default ports. What I have done while installation, I have made it 9000, and this DFS that is distributed file system master, I have made 9001. Okay, this all will be there in documents. If you see, you have configured users need to be the same user using which you have logged in. For example, here we have logged in as Hadoop user, so I am using the same username here. Right, now you can go and you can configure DFS. These are the properties which you can configure. DFS data dir, where you want, right? All these are properties. And so this is what we will be doing once your setup is also ready. See, whatever we have specified there, it has come here. This is what is FS default name, HDFS 9001, where it will get mounted or where it is mounted. So you will have this as development environment, which can be a Windows, and you can have a box which I am talking about, where you will have your HDFS file system installed. Okay, so you see all these are properties, and this is what we need to go through. Once we are aware about all these properties, which I will definitely discuss with you step by step once we start. Right, sometimes what happens, please be aware that this is Eclipse plugin. So sometimes some properties may not be visible here in this particular setup. So be careful when you are setting up the properties. You see log file count, log file size, right? So all these properties are there which we have to explore. Okay. So as of now, I am not setting up all properties. I am just showing you. Click on finish, and if you see now, you have your Hadoop server. Right? Are you exception because I have not specified the MapRed directory which we have to do. Okay. If you see this side also, you will have a Hadoop server. One failure it will show, that is unknown protocol, because I have not set up the appropriate MapRed, and that is not genuine as of at this point of time, because first all machines should be set up, whatever are there, and then we have to go and we have to adopt the protocol. So, and now from here onwards, it's all, see, you have mapper, user, and you can create a project. You see MapReduce project, click on next, test, right? You can go and specify Hadoop library. If it is not there with you, you can configure a directory wherever you have installed Hadoop, right? In my case, it is there on the local machine as well. And let's go here, and if you see, I have Hadoop installed here. Apply. Okay. Right. So this is what. Go with next. It will automatically pick up directories from there. So this is how you will prepare an environment for development. Okay. So once Hadoop is set up with right parameters, it all becomes what? You see libraries. You can go and you can add. And just go and click on finish. If you see here, project is created. It's building workspace. First time building workspace may take time. Now if you see here, you have all libraries, Hadoop core. Right now in this you can go and you can write the code. New, others, what you want to write. Two phases are there, mapper and reducer. I'll go and I'll com.test. From here it's all my mapper. Click on finish. Now this is the place where you will be writing the mapper. Okay. And similarly you can go and you can write reducer as well. Now in this you have to write logic. Fine. Now if you see the code is ready, once environment is set, you will be able to write and we'll be able to deploy it and we'll be able to execute. Right, so this error is coming because of JDK, so I have to reconfigure the JDK for this. That's everything. So this is the, so development environment is not at all very difficult. You can see from here that quickly we have gone and we have created this in matter of seconds. So once everything is set fine, you will get your Eclipse along with Hadoop. You have to just go and run the program selecting the server. So you have run on Hadoop. Okay, so I have to see your setup first and then we will start working with Hadoop. So what you need to have here is what are the steps that you have to follow in order to download or prerequisites that you need to have here. Pretty simple. You need to have JDK. That is what is first prerequisite. You need to have JDK. Ensure that you are having right JDK, that is at least 1.6 or above. Right? This is what is first requirement. Second, download Hadoop distribution. Third, create user, assign privileges, and once you have done this, fourth step is extract Hadoop and start the server, right? After you have done all these 4 steps, you have to go and set up the client. And for setting up the client, you have seen Eclipse here. We need an Eclipse download with the right build. Okay, so as of now it is Europa. You can use Eclipse 3.3.1. I will be providing you all links and a document post session for download. If you will use any other apart from Eclipse 3.3.1, you may face problem or you may be in problem. Okay, so in order to avoid this problem, we will be using the right Eclipse where we can use plugin. Okay, and this plugin we know is called as MapReduce plugin. Fine. So this is how actually you will be starting up with Hadoop. So Hadoop installation is what you need to do on your system. For that you have a choice. Better is to go with virtual machine. Once you have installed virtual machine, you create a machine. If you need a step-by-step process to do that, I will be providing it to you. Apart from that, you need to just download VMware Player, and I am going to share with you the image. Okay, so that there you need not create any kind of virtual machine and all. Okay, so what is prerequisite? Next session I want you to have what? VMware Player. Now VMware Player you can download from internet. If you see here, if I just go and show you from where you will be able to download and what actually you need. I'll go here, VMware Player for Windows 7, right? And just download, nothing else. Don't download Fusion and all, just download because this is free. So for Windows people it is free. You have to just download this and install it. That's it. And then I'll be sharing one document as I told you. I'll be sharing the image itself. It will be some 200 MB or what, and you can use that image directly. You need not worry about any other thing. You can download this. I'm sharing this with you. Once you have this, then we can start together, like trying out with file system commands and configuring Eclipse and all, right? I have configured this long back. Library issues are coming that I will resolve. This is what you have to do. And for second one, you can copy the link which I'm sharing here. You need to just go and download Eclipse 3.3.1. Download the right version. Please ensure that version is the right one. For your operating system, you can select. Okay. And you can download from here. Or else I'll share that one as well with you. I just want you to work in client server environment where your Hadoop is on a different box and you have a different, your client is on a different box. I don't want you to go with 4.3. Right, you can download it from here. I'll share this with you. Only these two softwares are there which I need.